Hello guys, my name is Craig and welcome to Premier Solutions. In today's video, we're going to talk about the logarithm function. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, we define the logarithm function by saying that for y is equal to b to the power of x, x would be equal to log to base b of y, right? Where x is a subset of rational numbers and y is also a subset of rational numbers, and y has to be greater than 0, right, for this condition to be satisfied. So in other words, this is a form that we can use to convert from exponential form to logarithmic form, or from logarithmic form to exponential form, right? And these are two important results that you have to know, right? That for any base, if we say log to base b of 1, we get a 0. So for any base, if you are saying log to base b of 1, we give us a 0. Why do we say this? Let's try and convert this back to exponential form or to index form. This would be in index form, this would be b to the power of 0, but we know that b to the power of 0 is simply equal to 1. So this result, we have to remember it, right? And then for any power n, if we say log to base b of b to the power of n, the result will simply be equal to 1. Why? Because we're saying that b to the power of n is equal to b to the power of 1. So the result is simply 1, right? So when we need to identify logarithms, we can just start by thinking of power, right? We can start by thinking of the power to which we can raise the base, right? So for example, if we are to find the value of log to base 2 of 16, right? And like I'm saying, if we think of the power to which we can raise the base so that we get the 16, we know that if we say 2 to the power of 4, we get a 16, right? So therefore, log to base 2 of 16 will simply be equal to 4. Then now for this one, log to base 7 of 343, we know that you can raise 7 to the power of 3 to get 343. So log to base 7 of 343 will simply be equal to 2, right? Okay, right, something else that we have to know is that since the logarithmic function is the inverse of the exponential function, right, we have to know that we can derive some properties of logarithms from the laws of indices, right? So these corresponding properties of logarithms, they apply for any base, right? And they are derived from the laws of indices. So we can say, so log xy is just the same as saying log x plus log y, right? Multiplication, addition there, and then division here, subtraction. So log of x over y would be equal to log x minus log y. The log x to the power of n would be n log x. So I just dropping the power to get n log x. And like I said, these apply for any base. So now I'd like to attend those questions. So allow me to raise this part here. Okay, so for number 1, we have to evaluate the following logarithms. So first part, we've got log to base 3 of 1 over 87. So now if you just think of the power to which you can raise this base, you get 1 over 87. We know that for 1a, we can raise 3 to the power of minus 4, right? 3 to the power of minus 4 is the same as 1 over 3 to the power of 4, which will give us 1 over 81, right? So therefore, log to base 3 of 1 over 81 would be minus 4, right? Then log to base half of 1 over 32, we can raise half to the power of 5. This is b, right? Here we'll get 1 over 32, right? So log to base half of 1 over 32 is simply equal to 5, right? This is equal to 5. Then log to base 6 of 216. We know we can raise 6 to the power of 3 to get 216. So log to base 3 of 216 will give us a 3. Like that. Right. Then for number 2, we have to write in the form y is equal to b to the power of x. So we're basically converting those logarithmic functions into exponential functions or index form. Right. So for number 2, 2a, we've got log to base 2 of 256 is equal to 8. Right. So in this case, our b is 2. Right. Then our x is 8. So I simply say 2 to the power of 8 should be equal to 256. Right. This is for the first part. Then for the second part, log to base 4 of 32 is equal to 2.5. We're saying that 4 to the power of 2.5 should give us 32. Right. And then for the last one, log to base s, right? Log to base s of t is equal to u. We're simply saying that s to the power of u should give us t. That, so that's an index form. Then now we have to write in the form x is equal to log to base b of y. B is following functions. So in this case, we know that we're saying log from 3a, we're saying log to base b, right? Our b being 7 of y, our y being 1 over 343 should give us minus 3, right? And then for part b, we're saying that log to base 2 of 1 over 16 should be equal to minus 4. And then for part c, we're simply saying that log to base p of m should give us x, like that. Right, that's how we express those. Then now moving on to number 4. Okay, so number 4 says express the following as single logarithms or as a single logarithm or number. Right? So we know how to carry out addition is multiplication, subtraction is division, right? That's the basics. So here we know we've got to base 5. So for 4a, we've got log to base 5 of 3 plus log to base 5 of 8. We're saying log to base 5 of 3 times 8, which will be log to base 5 of 24. So this will be the final answer. Then for part B, 2 log base to base 5 of 6. First, we can apply the rule that log to base x to the power of n is equal to n log to base x. So now if we raise this 2 to the power, it will be log, right? So it will be log to base 5 of 6 squared minus log to base 5 of 8 n plus log to base 5 of 12, like this. So now this is log to base 5 of 36 minus log to base 5 of 8 plus log to base 5 of 12. So log to base 5 of 36 plus log to base 5 of 12, we know this is multiplication. So this will be log to base 5 of 36 times 12. And then minus log to base 5 of 8, that's division. So dividing by 8. And this will be log to base 5 of, here we can simplify this by 4 to get 2. Then we get a 9, then 2, then 6. 9 times 6, that will give us a 54. So log to base 5 of 54. And then for part C, we've got log to base 5 of 3 plus 2. So log to base 5 of 3 plus 2. But we know that for us to get the 2, it means this, we could say this 2 times 1, such that the 1 is log to base 5 of 5. You still remember that important result that we talked about when we said log to base b of b will give us a 1. So this is how we're going to apply that. And we're going to raise this 2 then, such that it's log to base 5 of 3 plus log to base 5 of 5 squared, which will be log to base 5 of 3 plus log to base 5 of 25. And if this is addition, then it means we're multiplying log to base 5 of 3 times 25, which will be equal to log to base 5 of 75. So that will be the final answer that we get. And then for number 3, we're doing the same thing. So for part C, this is supposed to be part D. Sorry, this is supposed to be part D. And then this is supposed to be part E. Like that. So for part D, we've got 3 plus log to base 6 of 10. So we're saying for part D, this will be 3 log to base 6 of 6, right, plus log to base 6 of 10. So if we raise this 3 there, this will be log to base 6 of 6 to the power of 3, which is 260, plus log to base 6 of 10. And if this is addition, then we are multiplying. So we've got log to base 6 of 216 times 10, which is 2,600. So 2,160. So this is the final result that we get for part D. Then for part E, I'm going to raise this. So for part E now, we're now saying that 2 plus log to base 10 of 8 minus log to base 10 of x. This will be 2 log to base 10 of 10 plus log to base 10 of 8 minus log to base 10 of x. So here if we raise this 2, we've got log to base 10 of 10 squared, 10 squared being 100, plus log to base 10 of 8 minus log to base 10 of x. So this being addition, we're multiplying, so we've got log to base 10 of 100 times 8, which is 800, and this being subtraction, which means we're dividing, right? So the final answer will be log to base 10 of 800 over x, right? And now looking at number 5. Number 5 says express in terms of log x, log y, and log z. So for the first part, 5a, right, we've got log of xy over z squared, right? So xy, we know that's multiplication, so we can split that together. So we can actually say xy first, right? And then if this division, then we know it's subtraction. So it will be log minus log z squared. And this we know is multiplication, so we're going to split and add, right? So we're saying log x plus log y, then minus log z squared, we're going to drop this 2, such that is 2 log z. And this will be the final answer. Then for the last part, which is part B, we've got log of x squared multiplied by x minus, so we multiply by x times y squared z, then this is being raised to the power of 3. So if we remove these square brackets here, okay, so this to the power of 3 is affecting this result here. All right. So this we can say this multiplication of x squared times xy squared z raised to the power of 3, such that we've got log of x squared plus log of x y squared z raised to the power of 3, like this, right? So now we're going to drop this power 2, such that we've got 2 log x, and then plus, we shall drop this power 3 log x y squared z, like that. And then now we need to just split this, because multiplication we can split it to log 2 log x plus 3, right? Now we can say log x plus log y squared plus log z, like this. And then you can further on write it is, let me write it here. You can further on write it is 2 log x, right, plus 3 log x, right, and then this is 2. If we drop the 2 here, that will be 2 log y. So 2 log y times 3, that will be plus 6 log y, And then 3 times log z, that's plus 3 log z. And we know 2 log x plus 3 log x, that will give us a 5 log x. So we've got 5 log x plus 6 log y plus 3 log z. So this is the final result that we have for part B. Okay, so this was looking at the logarithm function and the basic properties that we have to apply. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.